very welcome to my presentation about future-proof power supply solutions. So a similar topic to the speaker before me, I would like to tell you more about how to provide hydrogen with benefits. First of all, some minor history of SMA and the SMA group. SMA is active since 40 years in the solar inverter industry and has installed more than 130 gigawatts of solar inverter power and battery converter power in worldwide grids. So they're the expert when it comes to grid integration of converters all around the globe. So 4 years ago, we decided to enter the hydrogen market with the same product platform, which is, by the way, IGBT-based, so very grid-friendly, and have decided to use this proven product platform for hydrogen applications. SMA is worldwide active with their own multi-million test lab in Niestetal, which also tests for CE and UL, so it already complies with European and also US standards. The Altenso group is a 100% daughter company of SMA and has already secured more than 80 electrolyzer projects all around the globe. Let me tell you how to use this experience from the solar inverter industry successfully in the electrolyzer business, as we have a capacity challenge in the coming years. As for example, the European Union is planning to install more than 100 gigawatts of electrolyzer capacity in the European grids within the next 6 to 5 years. In comparison, we installed 200 gigawatts in 20 years in whole Europe when it comes to PV installations. So how can we really install 100 gigawatts of electrolyzer capacity in 5 years only? We need to make sure that the products we install are grid compliant in Europe or worldwide and also stabilize the grid instead of harming it. Additionally, the technologies which we are using need to be scalable and also standardized, otherwise we will not reach the target. The companies need to be bankable and have the production capacity so that we deliver the products in time. PCUs are the connection point between the electrolyzer and the grid. They are converting the AC current into DC current for the electrolyzer, like you see here in the picture. We are focusing on a modular approach where you can install, for example, a 5 megawatt unit for solution in mobility or 100 megawatt for a solution in refineries. It's a modular, scalable approach, which we are using. And we, of course, there's always a discussion about topologies. We heard it already in the presentation before. There are different topologies, such as, for example, thyristor, which was the typical technology used in the first hydrogen projects because they have the ability of operating at very low voltages and high currents. The IGBT-based rectifier, which we are using, derives from the solar industry, which operates at high voltages and moderate currents. The thyristor-based rectifier always needs a power factor correction for the reactive power used by the thyristor. Additionally, it also needs filtering for harmonics because the harmonics needs to be at a low value to not harm the grid. It's a regulation of the grid operator to making sure that the grid is stable and operates safely. So the thyristor-based rectifier will be always a project-specific approach. Of course, there will be some projects where a thyristor-based rectifier makes sometimes sense because of the capability of high currents, but please consider that we need to install very high capacities into worldwide grids and that we need scalable solutions which are standardized. And the thyristor is always grid dependent. So you need always a grid-dependent grid study and also engineering when it comes to the transformer, which is also always a very complex phase-shifting transformer, for example. You also need to consider additional efficiency losses and additional footprints for the components which are here shown as power factor correction and harmonic filtering. So for comparing the different technologies, please consider always the whole system, from medium voltage to the electrolyzer. The IGBT in comparison also has a rectifier, also uses a medium voltage transformer and a switchgear, but there's no need for grid-dependent site studies or also compensation units. Let me show you how we do see the future of the market. We do believe that we need to provide hydrogen with benefits, and we need to be the grid's best friend. Otherwise, we will not be able to install the capacity in such a short amount of time. We can provide grid support services with IGBTs, which can provide additional benefits other than only providing the current for hydrogen. So your electrolyzer can provide hydrogen, but also additional grid services to the grid operator, like, for example, fault right through, which is the ability to stay online on the grid and also provide, for example, reactive power to eliminate this grid fault. It is very important that the electrolyzer does not disconnect from the grid, and European and German grid operators are discussing this feature, for example, very much. Then reactive power is also one important grid support service, especially when you connect a big electrolyzer system to the site. There are, for example, pumps and additional BOPs which need reactive power. The IGBT can provide additional reactive power, and you don't need additional equipment to, for example, compensate for that. So you can also save capex on that and also footprint. Voltage control would be an alternative regulating mechanism of the rectifier, which would ensure that you monitor the voltage at grid connection point and that you keep it stable at a specific voltage level. This would be also possible with an IGBT. Harmonics, we heard it, harmonics are causing stress on components within the grids, and this is why grid operators are requiring low THDI values. THDI is total harmonic distortion on current, and this is also always required as low as possible. And IGBTs have already very low harmonic distortion, so you don't need additional harmonic filtering. The other support mechanism would be, for example, to support the grid when it comes to frequency. And there, the IGBT is very flexible when it comes to the regulation of the IGBT. So it can also dynamically regulate the active power, where we can impact the frequency at the grid. So with these whole support services I explained, we can provide with SMA, Altenso, IGBT rectifiers without any additional equipment needed. Our solutions are completely plug and play. So we already integrate the transformer and medium voltage switchgear and the rectifiers inside the standard sea shipping container, which is very practical because you can ship it all around the globe or transport it via truck. It does not need any additional equipment. Like I said, it's pre-wired and pre-tested already. So you connect it to the electrolyzer and to the grid, and this makes it very, very simple. Additionally, we already have projects with PEM electrolyzers, SOEC electrolyzers, and alkaline electrolyzers. There's no difference between the technologies. It also has already the grid compliances because it derived from our solar inverters, and we already installed around 130 gigawatts in worldwide grids. This is very beneficial when it comes to the scalability of our products. Our products are also complying with IEC and IEEE standards, and the design is for 25 years. And we also consider harsh environments always. So the product is always tested at very harsh climate environments. And it has also C5 rating for installing the components, for example, also close to the sea, which is also very important. We do have also different options like cold temperature option, hot temperature option. This is not a problem at all. The scalability is also ensured because we are producing in series. It's not a project-specific production. It's a series production where we also utilize our standard series production in Kassel, where we have a production facility of 21 gigawatts production capacity per year, and we are currently doubling it to 40 gigawatts a year. It's not only on paper, it's not only presentation, but we have already secured 80 projects in 18 countries worldwide. Especially in Europe, in US, we are very strong. We have also sold our first projects in New Zealand, in Australia, India, China, and we are also focusing on Latin America. These are, for example, some of the industries we are already active. For one of our first projects were a smaller mobility project, which is the fueling station in Paris, which fuels the taxi fleet of Paris. Then we do have also one of the biggest PEM electrolyzer systems in Europe, which is a PEM electrolyzer producing green ammonia in Spain. We do have also some industries like in the glass manufacturing, also in refineries, and also forklift. We even have one station installed as an offshore platform, so we have our 20-foot container station ready to be installed on offshore platforms, and also many more. This is, for example, the biggest electrolyzer system in Portellano, Spain, which is a 20 megawatt electrolyzer utilizing our 20-foot container stations. We could save much money because we don't need any building, so you can install it directly outside and save on the building. And here we are producing green ammonia, utilizing a nearby solar park. And yeah, this is the current biggest PEM electrolyzer facility operating in Spain. And then we do also have a hydrogen production facility operating in Georgia, US, which is the biggest electrolyzer facility, also PEM electrolyzer facility currently in commissioning, currently already operating in US. And the hydrogen used will be used for different applications in the industry and also in the transport sector. It's 40 megawatt electrolyzer capacity. Yeah, let me tell you more about our references and how we can make your projects reality with using very grid-friendly rectifiers. Yeah, and meet us at our booth at A08. Thank you for your time.